let's put it all together. So at the end of the day, you learn the algebra for exponential and logarithms because you need to be able to sketch and analyze. One of the functions that you'll be analyzing next year is inverse functions, and that's probably one of the more relevant ones when it comes to exponential and logs. So here we go. Let's do the first one over here. I'm just going to find inverse equations. So in question 3, you can see here it says find the rule for the inverse. Now next year, when they ever say find the rule, I want you to write it as function notation. Okay, so we introduced that idea last term, and I'm going to do it again over here. So here we go. Let's do 3a. 3a, you've got the question, f of x is equal to 3 to the power of x plus 2. They want you to find the inverse function. So back at what you remember from last term, how do you find the inverse function again? What do you have to do? How do you find the inverse function? Yes, Dylan.
Y is equal to f of x first.
Good. This is how I would want you to write it. I would write let f of x equal to y, because they're using f of x, and then I would then say here that the transformation xy becomes yx. So this is what we did last term when it comes to inverse functions. We're saying that x is going to become the y value, and whatever the y value is, it now becomes the x value. Okay, so if we do that, what changes right now is that my equation, which is y is equal to 3 to the power of x plus 2, now becomes x is equal to 3 to the power of y plus 2. Your job is to rearrange that. Now, most students can rearrange this by saying the opposite of plus 2. You know that the opposite of adding 2 is? Very good, minus 2. Okay, so opposite of adding is minus. So this is what you're good at. You're saying opposite of plus is minus, and you minus both sides by 2. So this step here doesn't seem like it's confusing for most of you, but what's interesting is the next step. So here, you've done x minus 2 on the left, and then plus 2 minus 2 cancels out, so you end up with 3 to the power of y. Now from here, this is what you've been training to do. You currently have an exponential equation with base 3. So this is a power, is exponential, base 3. What's the inverse of exponential? What's the inverse of exponential? Log. So here, what you should be doing, just like how you've been doing plus and minus and times and divide, you should be writing log base 3 of the right and log base 3 of the left. And this is what I find the students don't understand. See, you can do the first line. You understand that. You say that's plus 2, so you minus 2 on both sides. Here, it's the same thing. If you want to get rid of the exponential base 3, the inverse of that is log base 3. But I did it to both sides. Same thing. It just looks different. But it's exactly the same thing that you've been doing here. If you found that easy, then this should just be as easy. It just looks different. Okay? So in this step here, we know that log base 3 of 3 are inverses, so they should cancel out. And if they cancel out, well, then the next step is you now have y is equal to the logarithmic base 3 of x minus 2. This is my inverse function. So what was hard about this step? There's nothing hard so far. If you understand this step, then why can't you understand that step? It's the same thing. Plus 2 minus 2 cancels out. They're inverses. Then I'm doing the same thing here. Log 3 and exponential base 3 are inverses, so they cancel out. So you end up with y. Same steps. But it's that main step there that I find students struggle. Right here, this is where you're memorizing most of the steps. You're learning how to change from exponential to logarithms, and you skip this step here. See, I'm showing you the steps because it's balancing the equation. That's all you're doing. So from here, how do you finish off the answer? We want to write it as function notation. F inverse, very good. So you never leave your answers y. That one I made up before. I said let f of x equal to y. If you're finding the inverse, you should write it in terms of f. So here we go. To write the function notation, remember the format is you need the domain, maps onto the codomain, and then f inverse of x is equal to log base 3 of x minus 2. So this is the answer you figured out. In year 12, you need to add on the domain. Now going back to what you remember about inverse functions, how do you find the domain of the inverse again? What is that equivalent to?
The range of the
Very good. The range of the function. So this is where it goes back to exercise 13C. Can you read the exponential graph? So here, this is your exponential graph. If you can figure out what the range of that graph is, then you know the domain of the inverse. So here we go. Let's try to picture what the graph is. So I'm going to draw my axes very roughly here. This is what my axis looks like. Let's have a look. What does the +2 do to the graph again?
Goes up by 2.
Goes up by 2. So I should already be saying that there's an asymptote, horizontal asymptote at y equals 2. That's what the +2 is. This is exercise 13C. And 3 to the power of x is a normal exponential graph. There's no negatives, so no reflections. So it should look like this. So now if I asked you, what is the range of this function, you would tell me? Very good. Range of the function clearly is greater than 2 because it can't equal to 2, and it goes to infinity. So that means the domain of the inverse is equal to, not including 2, to positive infinity. This is how you should be writing your answer at the end of year 12. So 2 to infinity. That there is 1 mark. Okay, so normally if it's a year 11 and 12 SAC, they normally give you 2 marks for domain and correct inverse, maybe sometimes method and then inverse, but just getting that step there, that's 1 mark. Okay, so that's what I want you to do whenever they ask, find the rule, this is how you should be laying them out. Okay, so that's generally your 2 marker all together. That's the layout I want to see. Okay, so that's exercise 13G. So I've done